All right, welcome to the episode 31. We have some special guests, balena people joining us tonight. Well, today, tonight, I don't know what's, it's tonight for you, right, Anush?
Yeah.
And for Alex and me, it's afternoon, and for David, it's morning. Guys, how are you today?
Good.
Yeah, I'm good.
Can't complain.
Good?
I'm good. I'm sorry we're a minute late. I thought JR is asking if there was a daylight savings time mishap. No, we're a minute late because it's the morning, so I had to go fill up my coffee. Sorry about that.
Yeah, this one's completely on David. The other three were completely ready.
Yeah, those guys were ready. I was not. But it reminds me of a couple weeks back when Kat was on the show and we had to wait for her to make her tea.
But that was tea time, actually.
It was tea
London,
time. Like, in fairness, it really was tea time. So, yep, 2 minutes late. It was my fault. Had to fill up my coffee.
All right. So, Anush, Alex, so we are usual suspects, David and me, but do you want to introduce yourself?
Sure. Should I go first?
Yeah. So I'm Anuj. I work on the hardware team at Balena. So that means one of the projects that I primarily work on is the Fin project, which I'm sure if you're a regular attendee at the Happy Hour, you've seen a bunch of it. But yeah, I work on Fin and Fin-related stuff at Balena.
Yeah, actually, you were on the first episode, right, of IoT Happy Hour?
Yeah, he was around for a couple of episodes in the beginning, but then he decided that this time was actually about his dinner time normally.
That's actually true.
Exactly.
Yeah, and decided, you know what, I'm going to start eating dinner instead of joining these guys.
Yeah, so it's my Happy Hour is my dinner time show.
Yeah.
I don't watch TV on Fridays. I watch Happy Hour.
Yeah. So, but
Yeah.
glad to
We
have
saw
you
some
back.
of your comments, actually. On
Yeah. Oh, yeah.
Yeah, I'm usually on comments. Yeah.
Yep.
Cool. And Alex, I don't know if you have been, you've been here, right, before on the IoT Happy Hour?
I've been in the comments. I haven't been on the actual stream.
Wow. So,
This is my first
welcome.
time.
First time. I don't know why I thought you were on one of them earlier. I started to lose track. This is number 31 already. So, yeah. Okay. Well, then, welcome. I apologize. I thought you had been on once or twice.
Yeah, first time.
Welcome. Definitely give yourself a good introduction then.
So I'm also a hardware engineer, same team as Anush, doing a lot of work on, in particular, the Fin at the moment. We've got some exciting stuff that we're doing that we can kind of give a little bit of a hint to today, maybe. But yeah, there's a lot of interesting stuff going on hardware-wise, and I'm deeply involved in that, and hopefully making some impactful contributions.
Awesome. Very
Super
cool.
cool. Maybe we can wait to talk about the Fin 2.0 after the what's on your desk. But actually, for Alex, will be what's on your room.
Yeah. I mean, it's not even going to be what's on your desk. It's what's all over your room. Yeah.
So my office has sort of slowly been taken over by me. You can see my 3D printer in the background. It's running Octoprint with the balena flavor of that. So I can send commands to my printer from my PC, wherever I am in the house, control it when I'm out. And then I guess I've got all my shelves and stuff, all my electronics behind me. Needs a bit of a cleanup, to be honest. But yeah, I'm a classic electronic engineer. All of my stuff is absolutely everywhere.
Well, I'm not an electronic engineer, and my wife complains that my stuff is also everywhere. So I can only imagine what. Yeah. Which one?
Hold
Alex, real quick. Which one are you running? Well, I was just going to ask Alex, which one are you running? The one from Matthew, his Octoprint, or do we have one of? I think we have one as well.
So it's a bit naughty, but I'm kind of running a version ahead of Matthew's one because I was updating it to the latest release. So I need to actually contribute that back. I haven't done that yet, so I'm
okay. All right.
Being a bit cheeky and keeping my own release.
You owe him a PR then, but I'm going to link to his repo, and he's been on the show. That must have been probably. It's been a while. We may need to check in with him. But if you look in the playlist, probably in the 8 to 10 episode number range, somewhere around there will be his Octoprint episode. But here's the repo for it, going into the comments now. There you go.
Awesome. So time for what's on your desk?
Okay, we got-
What's on your desk?
Yeah, Chris is watching, but that's the best we could do. Virtual Chris today.
Yeah, you can join to sing it, Chris.
Yeah, he can join in and sing if he really wants to. All right, who wants to go first for what's on your desk? I don't want to show mine yet because it's going to be the bulk of the episode today.
Okay, I can go. Okay. I have.
Wait a second.
Whoa! What is this mess? This is is this you must be an electrical engineer.
So, how do I go about this? Yeah, so this
You're good.
is,
We can see it. Yeah.
I don't know if you can see this, but this is like an OLED display that shows my CPU, RAM, and temperature from my PC. This is inspired by something that you guys did on the YouTube stream, which is a short video of an hour and a half hours, I think, for Balena. But this is the same thing, but OLED display, and it's not a Balena device. It's my actual PC.
Are you sure about that? It looks kind of small.
Yeah, this is actually like Udo Bolt, which is like a really tiny form factor AMD mobile processor.
Oh yes.
But it's stacked. It's like it's got dual drives. It's got an eMMC on board. I have an SSD and a hard drive there. Plus, it exposes Seed Studio Groove connectors and stuff like that. And yeah, it's pretty beefy, like for this form factor. So think of it as like an Intel NUC, but with the AMD inside.
I was just gonna say. So it looks about the size of a NUC.
Yeah,
but
it's
an
slightly
AMD
beefier,
processor.
but like very slightly.
Yep. Very cool.
So yeah, I just fetch the CPU, RAM, and temp from my PC here, and then just show that here. That's on my desk, and then this is some microcontroller work that I'm doing, which is messy. But this is like a breadboarded microcontroller that I'm kind of working on.
Okay.
And
I think the most important thing I can see in this screen, in this frame, though, is at the bottom left. Is that a Game Boy?
yeah, so it's like it's called a Pocket Sprite, which is essentially like a small ESP32 Game Boy thing.
Wow.
It's completely open source, so you can put whatever you want in it. And this is the case.
Yeah, I can see that. But wait a minute. That case is bigger than the Pocket Sprite. What is that case for? Hang on a minute.
That's a case for the fin.
Oh.
So my fin actually.
Awesome. Did you print it yourself?
Yeah,
Yeah,
wait a
and
minute. Where did you...
The barrel jack isn't correctly mounted, but this
Well,
is the fin.
That'll be for the net. Just cut a hole in it.
Yeah, exactly. But yeah, so it's on our GitHub if you want as a 3D printable
Okay.
case.
So that's
fin.
available.
That's good to know. Yeah.
Yeah, that's really good to know.
Yeah, that's available. And you can send your pull requests to one Mr. Konstantinos.
Okay. It's a pull request for a power hole through it. So
definitely
add a circle for, and then Alex has got the printer right behind him. He's ready to go.
Yeah, I think he must have a couple of cases printed already.
Actually, I haven't tried printing the case. I did a very, very early version, and then I messed up all my settings. It came out as a big blob of filament, and then I was like, I'll wait until we have an actual final release for that 3D model, and then I'll have a go at it again.
Let's see, where's that? I see iShop JR's got a comment in a 3D print case.
I posted a link in the. I posted a link.
Ah, perfect.
Awesome.
There you go. That's
so
what
anyone
I was
with a
just
3D
Googling.
printer and a fin can have a sweet setup like
Nice. Thanks, Anuj. Yeah.
that's what's on my desk.
Awesome.
Some of the things I can imagine. But yeah, take them for next episodes. Alex,
Yeah.
so what's on your desk?
So I got a couple of things I picked out. My desk as someone who's just a complete mess. So I'm going to just pick a couple of things and hold them up instead.
No, I want to see the mess. That's unless it's top secret.
It's more my webcam's going to end up being like hanging off the edge of my setup, but I'll hold some stuff up. So this is the thing I've been working on recently. So I know David knows a little bit about this, but one of the things that I've been interested in, see if that focuses, is the Ultra 96 platform. So this is a Ultra 96 FPGA system on chip board. And the board that I held up next to it is a PCB I've been designing for it. So the Ultra 96 is part of the 96 board family, which is like a standard for small board computers. So similar like the Raspberry Pi form factor is a small board. The 96 board is also another type. And one of the issues I've been having trying to develop on this board and doing some of the stuff with the FPGA on it is that all of the voltage output is at 1.8 volts, which is fine. But the problem is that most of my sensors and most of my hardware trying to interface with it is at 3.3 volts. So this board that I designed is going to be a level shifter plus some extra features for doing like power over USB-C and also USB to UART interface as well. So I need to populate this, but then once I've got my ICs on there, I can reflow it and then hopefully it'll work. You do it yourself or you send it to? So I designed the board myself. I had it manufactured and then I'll do the soldering myself. Okay. Wow. Really cool. That's
Sahaj
awesome.
Is in the comments. Sahaj is now he's asking, is that board open? So hang on a second.
Sorry. It will be. I'll be posting the source for it once I've actually checked that it works.
Okay, after it's working. All right. So very cool. Sahaj is an application engineer on the 96 boards project, or 96 boards team, I should say. So yeah, he's definitely interested in that one. And then if you don't mind, it's got the open source hardware logo on it, ready to go.
Yeah.
And I think if I recall, well, you know what, we can just get him on an email chain or something. But yeah, looking good. All right.
Yeah, I see the comment about the mezzanine. Yeah, it will be something I want to contribute back because it's something that's kind of missing from that family of devices. We need to have something that's better for level shifting. And then my plan later on the line is also to maybe look at doing the high-speed interface as well. There's a couple of mezzanines that do MIPI cameras, but again, there could always be more, and they're not easy to get hold of. So if I can get an open source one out there, that'll hopefully help a bunch of people.
Yep, absolutely.
Really cool. We need to do an episode about FPGAs, David.
I've been bothering which direction? Somebody down in that corner for a while. Yeah. So yeah, we'll do an episode on FPGAs.
Let's wait that he solds the pins of
this board. Wait till that board is ready to go, and then we can have Alex. We can actually, Sahaj has been on the show before as well. We can have him join. And do an episode strictly devoted to that topic. Yep.
Good.
Absolutely. Let's see. So, okay. So actually, just to go super quickly on my desk. So I do have these. This is new Chinese stuff from AliExpress. Thanks to Chris, I got addicted again to AliExpress. So I got these Ys. I learned this name. Or a clam. You will see that today it's about messy tables. To hold some of the cables that I needed to hold for the IoT Happy Hour this week. I needed these that just arrived on the perfect timing.
Yeah, perfect. All right.
What's on your desk, David? Can you show?
Well, I can show.
Or?
I can. AliExpress online gambling.
That's actually like Lucian has a very hot take, and I think that's right.
The thing about AliExpress is I don't like waiting 2 months for my.
No, now it's like
the best thing is you order something, you forget about it, and then like a month later, just turns up and go, I forgot about that.
It's like Christmas present.
If you play your cards right, it's like Christmas. That's true.
Yeah. All right. So yes, as Mark mentioned, the fire extinguisher is on standby. But we are gonna fry some balenaFins today so that you don't have to. So we're gonna take one for the team and sacrifice a fin. but hopefully it's for the greater good, and that way when it comes time for you guys to deploy your projects, you don't run into these issues. So Mark, you want to actually kick off the conversation?
I have a question before.
Yeah.
This is the one that get into your roof 20 episodes ago?
That is true. It is back down. I climbed up and retrieved it. I guess a couple of weeks ago. Let me switch my camera back now.
So you were claiming all the time that it was impossible to kill it.
Well,
so you made it happen. Finally,
there is a way.
31 episodes later.
31 episodes later. Well, that was an early episode, yeah. So roughly, 25 to 30 episodes later, we were able to finally kill this fin right here. But it survived for the most part throughout the summer up until we reached a point where, and if you remember some of those early screenshots that I had posted and the link to it, the highest we got was 108 degrees Celsius on the board. Now, what would happen though? Yeah, there it is, exactly. Dude, I thought burning boards live was my thing. Yes, the Hajj has killed many boards live. So I always laugh when he does it too, every time. But so the fin would reach a point at about ambient air temperature of 97 Celsius, 98 Celsius, CPU temperature on the Pi of 107 to 108 Celsius, where it would go into USB shutdown. And that's actually designed as a feature. Alex or Anuj, you know of that one. Anuj, you did some work to investigate and resolve the issue. Mine is an early board that did not have some of the additional protection or circuitry that you guys deployed and have written a blog post on. I think Nico wrote up a very detailed analysis of the issue, but mine doesn't have that fix. So it would go into, it was a protection and shut down. So yeah, at 97 Celsius, it just couldn't make it. So I brought it down from the roof a little while back now and decided, all right, we're going to kill this thing. And I know how. the heat couldn't kill it.
I think you can have a little hope because I think if you reset the fuse, if you change the fuse, I think you might be able to bring that back for some more action.
Yeah, I think you can resurrect it. Yeah, I did it during this week. So
yeah, we'll see. I don't know exactly how I killed it the other day, and we're going to talk about that. I'll let you guys sort of start out the conversation, and then we'll circle back to what I did wrong. So,
all right. So actually inspired by the blog post that Chris published on Balena. Let me put it on the chat. If you haven't read this blog post here, do it, because Chris explains how to create a solar-powered weather station with LoRa to the Things network. And on the second part, which actually we can link in a second, he explains how to put a Raspberry Pi with Balena OS to get all the data from the Things network and visualize it with, I guess, it's Grafana and InfluxDB. So actually inspired by that, so David had the great idea to put a Pi Zero with cellular connectivity with a solar panel and a battery in the middle of the desert of Arizona. He wanted to go riding his bike straight during the IoT Happy Hour, but I suggest him hold for a sec. Maybe first we should learn how to measure power consumption of your Pi Zero and cellular connectivity. And actually, because I do have my balenaFin with U-Blocks or Kectel modem on the PCIe, why don't we start with balenaFin, measuring how much it the power consumption of the fin. But then we had fires at home and fireworks and so on. So this is why we called the specialists.
That's why we get the experts over there, because I was about ready to go get on a bicycle and take a drive out to the desert with a Pi Zero our Twilio SIM card with the Quectel modem, which is, we did a build of a couple weeks back, and this little USB battery pack. Well, it's not little, right? But I was about to go toss these things out in the desert looking for javelinas, but I thought, you know what, we better figure this out first. Get the experts in here, see how much we can get on a battery pack like that. So
probably for the thing that you need, right? It's a multimeter, maybe, no? Well, actually, I have the same that you have. Probably it's the cheapest one on Amazon, right?
Exactly.
But that's
could have saved a few dollars on AliExpress, but
but it's online.
I didn't want to wait. Yeah, but it's the online
probably,
gambling.
But probably we will get like different multimeters from Alex and Anush in a second on his
more professional
webcams.
Equipment,
more professional ones,
yeah,
because we will let you know why this sucks. If you want to measure power consumption of Fin, and usually when it gets to sleep, you will see that this is completely useless. So gentlemen, how do you do to measure power consumption of an IoT device?
So this has been something that we've had to look at a couple of different times. So when we first released the Fin, we had a bunch of different ICs on the original 1.0. And there were some issues regarding how expensive that device was, particularly in regards to some of the chips we had on it. And when we iterated to the 1.1, we ended up pulling some of those off. And one of the things that we gained with that was obviously some power savings from removing that feature, or not feature, removing that extra IC. So we have gone through, we have tested this stuff previously. The easiest way to measure power on the Fin is to simply measure it at the source input. So what I'll show you guys in a second shortly is how I set up with my power measurement. There's two different ways of doing it. The one that is like more generic, which is just with the multimeter, lets you very broadly measure the current going into the device when it's powered on and when it's powered off. But something that's worth noting is that if you're trying to measure really small amounts of current, you may need to use a more specialist tool. And I'll talk about that. I don't have that set up today. There's a bit more fiddly to set that up, but I'll talk about how to use this other tool and why you would want to do that.
Right. And second, during our research, actually, there is a blog post that I'm going to put on the chat comments, where Nico, actually, who couldn't join the IoT Happy Hour because he's on support shift, but he may let me put it here. So he explained actually how the power consumption on the balenaFin works, actually. And if you go there, you can see all the details of how it works, etc. So one of the questions I had is, hey, is there any application on Balena where I can test different status of the balenaFin? Like, how can I put the balenaFin on maximum CPU or maximum power consumption, or minimum, no? And actually, for the minimum, we have to explain that after the summit that actually we made an IoT Happy Hour, there was a Balena Hack Week, and one of the teams made by Alex and Phil developed a project called Finabler that really easily gives the tools. It's actually a blog, like John explained last week what was a blog. It's a blog that actually gets installed on the balenaFin and with other containers if you need that, and actually enables you to easily, with a API call, sleep the compute module. Okay, the compute module on the Raspberry Pi in just a post call with a REST API, as we are going to show in a bit.
Yeah, so I think it's important to kind of remind people, because one of the key differences between the Raspberry Pi and the balenaFin is the coprocessor. And that's what really enables the stuff that you're talking about. Because if you want to put something down and sleep, you need something that will wake it back from sleep, right?
Exactly.
So there's
Tell us more, about the coprocessor, Anush.
Yeah, that's Alex's favorite topic, actually.
So this has been a little bit of a love-hate relationship sometimes with the Fin. is that we have this fantastic thing that's the coprocessor on board, but it can be a bit of a pain to work with it sometimes. So some of the things that we've been doing the last week, and an effort between Phil and myself. You guys had Phil on before, haven't you?
Oh yeah.
So we had a hack week at the end of our company summit a few weeks ago, and one of the projects that Phil and I built was called the Finabler, or the Fin block, or whatever anyone wants to call it. And it's a bit of a proof of concept at the moment, but we're working on kind of fitting this to the kind of things that people want it to be able to do. And one of the things is it controls the coprocessor directly to be able to set the fin into different sleep states. So a really easy way to drive it is it simply it opens up a REST interface on the balenaFin. And so you could ping it an endpoint that says, I want it to sleep for so many seconds. And then the board will go down and the microcontroller that's on board will track how long it's asleep for. And then at the time it expires, it'll wake it back up again as if nothing had happened. So you could use this, for example, if you had a device that was battery powered, or maybe even solar powered, and you had to charge a battery. You could wake up, check the state of the battery. If you see the battery is not fully charged, go back to sleep, wake up again in 2 hours, 3 hours time.
Yeah, that's really cool. I mean, and actually there are a lot of balenaFin customers who are using the coprocessor, right?
We have a few, yeah.
So that's very, very useful. And now there is like a block that, it's on the chat, and here you can see it here, that you can use, and in a really easy way you can send to sleep the balenaFin, but from the version 1.1, right?
Yeah,
the
so
1.
from
1.0.
1.1 onwards. 1.0 has a hardware issue that prevents it from sleeping. That was why 1.1 came out, was to fix that issue.
All right. So let's get some power measured. What do you think?
Yeah, we can give that a go.
Let's do it.
Try and move my setup across.
You have a fire extinguisher at your home, Alex? Or you don't need that?
I have the window right next door, so I can just throw it out if I need
to.
Yeah. Either I jump or throw it out the window, you know.
Yeah, save yourself or the fin, one or the other.
Yeah. Okay.
Okay, let's see if we see something or not.
If we do see something, but it's a little bright.
Yeah, but
right. The lighting.
Alex,
hold on. Let me see what happens if I change the layout. I guess it's just going to bring a larger version of
So maybe David, you can explain how did you generate the smoke from your balenaFin?
Yeah. So we lost Alex. He went too far from his Wi-Fi. All right, so let me change my camera back, and then Mark, when he gets reconnected, bring him back in.
I will reconnect him. Yeah.
All right, so let me get switched back, and I'll tell you what I did so that you don't have to. Okay, there we go. So the electrical engineers on the call are going to laugh at me, but what happened was, let's get set up. I had my fin plugged in like so, and I then took my multimeter, turned it on.
What did you try to do, by the way?
What I was trying to do was measure the, oh, wow, Alex's came in great. So I'll go real quick while Alex is just getting set up there. So what I was going to try to do was, let's start off with a very quick check to see if I was pulling 12 volts in, to at least just check to see that that the multimeter was accurate and that the probes were working. Okay, so simple enough.
Volts, right?
What's that?
It says 12 volts, right?
Yeah, it says 12 volts. I mean, it's it's still pulling power. Now, here's what happened that let the magic smoke out of this board. I'm going to be careful not to do this again because I think that the fuse is already blown. But when I lifted my probes, and actually, you know what? Hold on. I'm going to unplug this just to be safe before I start a fire.
Yeah, he was first measuring the voltage, not the current. Yeah.
Okay. So I had my probes in here like so. When I lifted up, I was not very careful, and I nicked this over here, which is the coprocessor header. And I must have still had, I guess, maybe the ground on here, or maybe I had it, I can't remember, maybe I had it backwards. I don't remember which side is the plus. Alex will be able to tell us in a moment. But either way, I nicked one of these coprocessor headers and sent 12 volts into the coprocessor. Now there's a fuse on board, so it may have just been that which blew and smoked my fin, but either way, it's now in a state that is not functioning. So yeah, I'm not exactly sure. I just wasn't paying close enough attention, but either way, it resulted in a dead fin.
So this is what Chris said, and Anush actually mentioned as well before the IoT Happy Hour. We think that you should change live the fuses to demonstrate that, that the system is well designed. What do you think?
I'll mess around with it while you guys carry on conversing. I'll give it a try. Mark, if you take my camera back out to smaller view and let the pros over on the left-hand side of the screen have at it.
So actually, Sahash was right. So you were trying to measure voltage, and we are trying to measure current. Mm-hmm. So this is why, so I killed one of the power adapters that I have and I made these. So probably now Alex will be able to explain the circuit that you need to do to measure voltage. So all yours, Alex.
Yep.
I made some zoom on your camera.
Sure. So you guys can hear me? I'm coming through all right, mate?
Yes. Yeah.
Okay.
You're good.
So the setup we got here is a bit unusual. We have power coming into the Phoenix connector on the fin. So this is just a cable I use for testing. It allows me to plug in different types of leads.
Okay.
And then what I have is I have that lead spliced. So I'm basically have a circuit running in parallel to it. So I'm tapping in one side of it, in series to it, tapping in one side, running it through my multimeter, and then back out the other side to the fin. And so when you measure current has to be taken in series with the connection, and then voltage you could take in parallel. So with current, you do actually have to splice your circuit as you're measuring the flow of electrons through a wire. So that's what we're doing here, basically, is that's running through the multimeter. And so we have 12 volts coming into the fin, coming first through the multimeter and then into the fin. And then the multimeter is measuring the current consumed as it goes through. So right now, we can take the calculation from for power. So we know that voltage times current gives us the wattage. We know that the board is being powered by 12 volts. And we can see the current consumption here on the multimeter.
Mm-hmm. So this is 116 160 milliamps.
That's correct. Yes.
Okay.
Yeah.
What is running on the? What are you running right now on the fin?
So right now, at the moment on the fin, we have just a actually we have the fin enabler block in the background, and that is connected over Ethernet just because it's faster for me to do it that way. You'll get different mileage depending on what you're using. So if you're using the Wi-Fi peripherals, and also like if you have a cellular radio on the back, you'll be consuming more power. Mm-hmm. So it's worth bearing that in mind if you want to do it. So I've just seen a comment about shunt resistor, and that's actually the next point I was going to make. This is fine for doing generic measurements, but there is some lossage that you'll see if you measure it this way, just generically. Yeah. Just for doing like a quick and easy, show you guys that we can sleep the fin, that's fine. If you do want to take more accurate measurements, let me just dig it out of my drawers. There's a device that I use, which is called the microcurrent gold, I believe. Let's find it here. So this one is specifically. Yeah. So this is basically a shunt resistor that lets you measure very accurately small currents. And so it's not ideal for when you want to measure like many amps. But when you get down to very small measurements like a sleepy microcontroller, this is where this is more important because it will give you a much more precise measurement than using a generic ammeter on a multimeter. Mm-hmm. But this requires a bit more setup, it's a bit more fiddly because you have to deal with changing from a high current state to a low current state, which is not the easiest thing to do, which is why I didn't bother setting it up today. But
Actually, I think that this is the device that Nico used to do the blog post about the power measurement on the fin.
Yes, he would have done. Yeah,
I think so.
And this is what I did my testing with as well. It's a really useful piece of kit. And if you do want to do microcontroller stuff with batteries, I definitely recommend getting one.
Awesome.
So what I was going to go on to and show you here was, and this is an early version of the 1.1 fin, which is why the PCB is green, and ignore the header coming off of it. Other than that, it's entirely standard. But what I'm going to do is I'm going to jump into my application, and I'll show you guys what the power consumption looks like when the fin actually sleeps. So I'm going to now send it to go to sleep.
So I'm gonna after this, I'm gonna share my screen to see how.
Yeah.
So you've seen now it's just gone. All the LEDs are turned off. We killed the power to the compute module, and it's now sleeping for 20 seconds. And you can see the current consumption's completely dropped. In fact, I think if I get it into so that's
this is 2.2 milliamps.
Correct. Yeah.
Wow.
And so that's coming from the microcontroller because that's the only thing that's powered on. And now the board's booting back up again. So if I put that back into full scale mode, you can see the board's come live again. And it'll take a couple of seconds before it boots all the peripherals, and it's back up again now. So what you would do in this situation is, using our application or however you want to control the micro, you would tell it to sleep for X period of time. And one of the things that we're working on with this as well is the ability to wake up from an interrupt. So sleeping for a period of time is great, but if you need to respond to something happening in the outside world, you need to be able to respond to external stimulus. So the next thing that Phil and I are working on is adding the ability to wake on an interrupt to the coprocessor. So say, for example, a door opened or it started raining or something and you needed a power on, you'd be able to detect that using an interrupt.
Yeah, so you can get into very low power and then just wake up the compute module, send data, and send it to sleep again. That's really cool.
Exactly, yeah.
So in that scenario that you just described, okay, an action occurs and the compute module wakes up and you interact or your application does what it needs to do. How does it know to go back to sleep then? I guess that's built more into the application side running on the compute module, I suspect then, or just some sort of a timer.
So what you would do is, it's worth bearing in mind that every time you power cycle the fin, it basically powers off. So when you boot back up again, it's starting from a state 0. So you have to understand again, this is something else we want to support with the fin block, is the ability to check the state. So you want to be able to know whether you woke up from a sleep state or whether the board was accidentally power cycled or whether this is the first boot cycle. It's important to know what happened before the board woke up, because you need to know how to respond to that situation. Mm-hmm. So what you would do is you would need to be able to understand, if I just woken up, is there some specific logic I need to handle now? Do I check the environment? Do I check a state for something else? If that's true, if that's false, then do I go back to sleep again? The thing that's important here to remember is that you lose complete control over the fin when it goes to sleep, because we're turning everything off. So if you do want to do things like send this board out into the field to sleep for 200 days, you need to be pretty certain you know what you're doing, because it's going to be asleep for 200 days.
Yeah.
Again, this is something that we're looking at with the next iteration of the fin, is how can we provide our customers with the ability to wake up a device that is sleeping for maybe the wrong period of time, or it's gone to sleep unintentionally. And so this is the kind of things that we're looking at solving with a new state of the fin hardware. But these are all things that are important to consider, and it doesn't really matter what hardware you're doing this with. You'll have to consider rogue devices that go to sleep in the field. So it's worth just being careful and being wary of what you're doing.
Gotcha. Okay, so you need to think about that. So I see Sahaj had a comment about whether the Pi has a proper C-state sleep. I don't remember too carefully, but I think they were C0, C1, C2, or whatever that over in the x86 world when I was reading about them.
So the way that we handle it here is we kind of do it a little bit ungracefully. So we do have a delay and a check that sets the state of the fin. We basically power it off via software, and then we click to cut the power with the control with the microcontroller as well. And we have the ability to force this as well. So if you knew immediately you had to kill the power instantly, you can do an ungraceful shutdown, which basically just immediately kills the power to the compute module. Or you can set it to gracefully shut down, which it requests the software power down, and then we kill the power.
We have some questions as well. So does the Fin have
It does.
RTC? Yeah.
Yeah,
No.
it does.
We actually have multiple RTCs if you want to be accurate. We have a physical RTC which is available to the compute module, and that's actually here. And
point back, please.
So it's just over here.
Yeah.
And so that's available for the compute module itself to track time, but the microcontroller also has its own RTC, which is what we use for tracking sleep.
Awesome. I don't know, David, if you can.
I didn't realize.
Or...
I didn't realize that it had 2 RTCs based on the fact that the microcontroller has one as well. That's very cool. But you can see. Let me switch to my screen, or Mark, switch to mine real quick. Because the battery, the coin cell battery in there is for the onboard one, right? Is that correct, Alex?
So that's the one accessible to the Fin, to the compute module.
There it is. That's right there. Yep. And while you guys were talking, I did swap out. You can see that's the old fuse right there. I took this fuse from here. I have not replaced it. I don't think it matters if it's blown anyway. And I put it here, but we are not looking successful. Still in its red LED status, no boot. So we may have done some permanent damage here. I'm not entirely sure.
You should try the Phoenix connector maybe, or I don't know.
The other barrel. Yeah, I could do that. Wait, when did David learn to solder? I have not learned to solder. I don't know what Sahaj is talking about. I have not soldered anything. I used the... Oh, hold on, let me unplug that again. I used the probe to just pry the...
Okay. Meanwhile, David is trying to to kill the fuse.
Yeah, I'm trying to kill it as good as I can.
What MCU is being used as a coprocessor on the Fin?
So this originally started out as a Samsung Arctic 020, and that family then migrated to become the Silicon Labs BGM 111. They're the same chip; it's just different branding on them. So if you want to find out more information, it's the Silicon Labs BGM 111.
Cool.
Mine looks, that's the Arctic logo. Let me see how close I can get before Blurry Cam. Blurry Cam is not, can't quite see it. But yeah, right there.
But yeah, I shot GR is
don't use your
remembering you that don't play with the probe.
Oh yes, you can. You absolutely can use them as prying rods. I can't quite get the model number off of it, but that's all right. Alex, if you repeat that out, the model number, or maybe I can. No, I can't quite read it. The text is too small. We can pop it in the chat.
So the chip is a Silicon Labs BGM 111.
BGM 111
from Silicon Labs.
Silicon Labs, and then if we can get some live Googling on that, we could probably get a data sheet off of that. But yep, there you go. BGM 111. Oops, sorry. And let's do a quick questions check. What do we have? Does it support Zephir?
Already Anush replied that if he was
we would have loved that. We did explore that internally, but the thing is that Scilabs has some licensing headers in their source code, which will not allow Zephir support. So there's so if you guys want to take a look, there's the Silicon Labs GitHub issue for this, where a lot of people have expressed interest, and yeah, I mean it's not resolved yet. Basically, that's the gist of it.
Okay.
You guys
Which is
show me my setup, or can I return back to my chair?
I think we're good. I mean, we demonstrated it. So, Mark, you want to show? We could let Alex sit back down, I suppose.
Yeah.
So we saw it working, and then Mark, you want to show the application itself?
Yeah, exactly. So I wanted to do the Charlie tips and tricks with the slipping the compute module of the Fin
Okay.
in a really easy way, as you made it happen with Phil and Alex on this summit on the Hack Week. Let's do that, and then after the Charlie tips and tricks, maybe we can talk about balenaFin 2.0, maybe.
Yeah.
But let's wait a sec. Let's call Charlie tips and tricks.
Okay, there's Charlie.
Anyone wants to sing a song, or
we don't know the word. There's no.
We need
so we don't
maybe
know
we need
what the song
three.
is. There's nothing to sing yet. We have to come up with a song before we can sing it.
All right. So the trick this week, actually, it's about slipping the compute module and getting to these 2 milliamps per second, as Alex demonstrated some seconds ago. So actually, I have my Fin connected, not with the Phoenix, but I got the normal bar jack, and So just to explain, I think it's in the chat, the Finabler, the Balena block Finabler. This enables in a really easy way to create an application. If you run other containers, just put this on your Docker Compose. This part here, just copy and paste and leave it there. So I created a really simple application with a hello world inspired by last week, Thomas, with a hello world with a Wi-Fi connect. So I made exactly the same, and I will pray gods that it will work.
Pray to the demo gods.
Exactly. But so we have a hello world that actually, if we click here, it should work. Yeah, so welcome to Balena. And on the other hand, we have the block to enable this API, this REST API to slip the compute module. So if I got into the host OS and I call post localhost, the port that actually is defined to do that, sleep, and then the time for sleeping time and the delay. No, it's in 10 seconds. No, it will sleep 6 seconds.
Yeah. So the first number is the delay for it to wait until it starts sleeping.
Yeah.
So we specify this as like a extra measure if you needed to do anything before it sleeps. So if you know I could start sleeping and then in 10 seconds it'll actually sleep.
Something that's very beautiful is that you use the tags to explain the situation of the Fin. So you are going to see on the tags here in the middle of the Balena Cloud dashboard that the status of the Fin will change as a wake to sleep, and it will appear like the wake expected time of arrival, the eta of the wake on a specific time. Okay, so let's try it. So actually, if you see this, the LEDs are on. So if I do this, it just says okay. And after the delay, you will see as well, first, the LEDs will turn off. But on the other hand, you will see that the status is sleeping and when it will wake up. Okay, that's really cool because it gives the information of when it's going to wake up.
So it's worth noting as well that you can make that call request from outside of the device as well. So you could either send it from another container, you could send it from the host OS, or you could even send it from an entirely different external source. It's just a REST API, so wherever you can reach it from, you could send it to.
That's really cool, man, because I remember that we had some calls a long time ago trying to make it, trying to run this sleeping coprocessor on my Fin, and it was pretty complex. So actually you simplified the way to sleep the compute module a lot with this block. And hopefully in next IoT Happy Hours we will have the hardware hackers telling more about the Balena blocks here live. Hacking some of the blocks.
Already seen Chris sending me feature requests even in the chat here, so definitely in demand.
Feel free to join, Chris. Come on, don't be shy. We have the virtual Chris, but
virtual Chris isn't as good as real Chris.
So actually, the LEDs turn on, and when the supervisor will see everything up and running, will update the tags probably to awake. So that's really cool. actually. Yeah, so it seems that it's getting online. Let's see. But yeah, whatever. So maybe we only have,
Yeah, we've only got 9 minutes left. Real quick, I see, Anuj, did you send that over? That's the Zephir issue there.
I mean, if Sahas can hopefully push some buttons and get that thing merged, we definitely benefit from that.
Okay, and then we had A13 chime in to Alex. The mezzanine you showed earlier, does that have a level shifter?
Yep. So the level shifter I have set up supports 1.8 volts, 3.3 volts, and 5 volts.
Do you mind holding that thing up again? Let's take another look at that thing.
Which way I'm going?
And that is a 96 boards compliant header on that.
The way that it works is it has the header for the 96 board, then right beneath it there's a Raspberry Pi compatible header, and then there's another breakout to the side here, which is just generic extra pins that we had available as well. And then the bottom is going to be over here, power over USB-C, and then UART over USB-C as well.
Where'd you get the PCB made?
So it's I think it's a German company called Elsia or Azia or something like that.
Cool.
They're quite fast for me, which is why I choose to use them. But I have used like JLC PCB before.
Gotcha. Very cool.
There are tons of PCB makers, right?
Yeah. I was curious which one you went with. All right.
Probably depending on where you live, no?
Yeah.
Some of them are faster than the others. And if you want to have 1 or 10, depends. Something it's... All right, so let's maybe get into the Fin 2.0, no? The news a couple of weeks ago of the Compute Module 4. So pop up, and probably you cannot talk a lot about these, but what can you tell us about the newest version of the Fin?
So...
we're working on it. That's the first.
Yeah, but I mean, so what the overall takeaway is this, and then you guys can dive into it. So, a couple days back, I actually tweeted out from the Balena account that we were, seeking input, right? We're literally asking the community, what features would you like to see in the next Fin? So you guys, you all just saw the Fin 1.0 and or 1.1 on our desks. But with the release of the Compute Module 4 in a new form factor, we're going to have to redesign or rebuild the Fin to fit that new format. Well, if we're going to do that, let's get some input from the community, right? What features would you want to see? So that link right there, let's get that. Is that dropped into chat?
Yeah, I dropped it into chat.
Perfect. So people can chime in. I mean, jump in on that thread. You can read through it. There's already some people that have put some input in there, but by all means, we're asking what should go in a new Fin. So then with that context, Anuj, Alex, if you want to kind of give some general themes that we're thinking through.
Yeah, I mean, we're definitely listening to the forums, because the forums are a pretty active place, right? Even without Balena engineers chiming in, there's a lot of activity, people asking questions, people making suggestions, and so on. So it's natural that we'll ask the community about what do you guys use, what do you guys miss on the Fin and stuff like that. Plus, we have insights from existing customers as well, right? There are some features that are more widely used than some other features. So that also kind of helps us to, pick features going forward. So those are kind of things that...
So to build on that as well, we've learned a lot of lessons from having done the 1.0 and the 1.1 and iterations and fixes of problems that we've seen in the past. And I think one of the biggest changes that I can sort of talk about with the next version of the Fin is how we're changing our story to be more software oriented. And so one of the approaches that we've had has been historically that all the hardware is discrete. So it all exists on the board itself. It's all in one place, in different ICs all over the place. And where we want to kind of reach is more of a modular story. So we have a Fin that is more adaptable for future iterations. So we can build up a base platform to support things like the Compute Module 5 whenever that comes out, or other different types of compute modules. And what we've done is we've moved or we are doing, is moving some of our story, which has been in discrete components, into software solutions. So the microcontroller that's going to be on board on the new Fin is going to play a much more important role than it has done previously, in regards to what the Fin actually offers, and how it does it, and how we enable the customer to do things with it. So we'll make it a lot easier for the customer to do things like sleeping the Fin, accessing peripherals, and also giving us the ability to directly control that in the field, so we can update those kinds of things as well.
Yeah,
David.
I've got in my hand the compute module 3. I'm wondering if I have another compute module. I wonder if I swap that out to, I wonder if I killed the compute module on my Fin. But yeah, obviously you can see here compute module 3 versus, what the compute module 4 format looks like.
Yeah, it's worth, I just seen a comment about USB 3. So yeah, we will be supporting all of the features that the compute module 4 brings. So USB 3 being one of those features, the PCIe lanes as well. And obviously things like multiple HDMI interfaces, that's also something we want to support.
Dual display.
Yeah, it basically just gives us the ability to power up our existing offering with some more features.
Yeah.
So there's a comment about beefing up the MCU with the IMX T series. Yeah,
So
that would probably be a little bit of overkill.
We have actually discussed that, but yeah, we have some reservations about maybe chucking that much power into a coprocessor. But there is a possibility that you could potentially put that on like the MPCIe lanes of the compute module 4, or if you want to do like extension boards to do your own thing, we're totally up for people doing that kind of thing. For us, we see the coprocessor more as a peripheral for the compute module in the next iteration of the Fin. So it's going to be something that makes that more feature full, I guess, than the current offering.
Yeah.
Very cool. Yeah. So feel free to go to the forums to
we definitely
to
want to
send
hear
your
from people about what they want. No promises, because
You heard it first. No promises.
Yeah, no problem. I mean, like I said, like there's a lot of public discussion around it, but then there's obviously customers with whom we have not so public discussions, right?
Right.
But
Customers, of course, will have, enterprise needs. Of course, there's, I mean, you can put every feature on the board possible, but then it becomes a, $1,000 board. And I mean, is that going to sell? I don't know. So it comes down to, you have to strike a balance, just like any other product design. So there might be things that would be nice to haves, but unfortunately don't make the cut. I get it. So
yeah, Alex is working on a $999 Fin, which is going to have an FPGA.
No.
A $999 Fin with the FPGA already in it. Okay.
Unfortunately, we're not at the point yet where FPGAs are affordable for us to consider. If you could find me an offering, I know I'll happily consider it. But I think the price constraint might be a bit limiting.
Okay. Maybe bridge the Ultra 96 right into it somehow.
I would love to have a Zinc compute module. That would be my dream. But I think I'll have to make that if I want one.
Yeah, I was just gonna say, well, you're gonna have to build it yourself. Yeah.
Yeah.
Get you in touch with the right folks. Get the parts sourced. There you go. All right. Well, looking at the clock, we are right at the top of the hour. Anything else? Any other questions roll in? Did you see anything else, Mark?
We have one last question from Arijit, but I think already answered by Alex. So if we will have some MPCIe, well, if there are MPCIe FPGAs,
so there are MPCIe FPGAs. They will not be compatible with the current version of the Fin because we only expose USB over the MPCIe interface currently. The next iteration of the Fin, we will be supporting PCIe over the MPCIe slot. So you will be able to get at least PCIe Gen 1 speeds from that interface. So, which is quite exciting for me and anyone else doing anything else with acceleration cards like that, because we suddenly have a high performance interface to do acceleration with.
I think there is a Google TPU, the Coral TPU, I think can be had in MPCIe form factor. So if I understand you correctly, would that not currently work on a Fin 1.1, but would potentially work on a Fin 2.0?
So if it communicates over the USB protocol, yes, it will work. And I've just seen a comment as well that we do support USB MPCIe devices. So as long as your FPGA or whatever your Google Coral communicates over USB, it will work. You just won't be able to access the MPCIe PCIe interface.
Gotcha. Okay. I see. Someone has commented that there are USB PCIe FPGAs as well. All right. Well, I hope those are not the $999 ones that you're talking about. But all right. So then, interesting.
All right. So today we learn how to measure the power consumption of the Fin.
Yeah.
How to sleep the compute module, and we will work this week to connect. Maybe you will need to get another Fin, to get to the Fin shop and buy
I've got to go to the Fin shop. Mine, I swapped that back out, and we are still just a red LED.
We didn't see any smoke. I think Sanj was complaining about that.
Haj wanted to see some smoke, but that happened on Wednesday while prepping for this episode.
Is this the one that you had at 100 degrees?
This is the one that I had at 100. Yeah.
Probably one's putting out of its misery. To be honest, it's probably ready to.
You know what? It's true.
It's to be in the Balena Museum, probably. So don't destroy it.
Yeah, this
is a good place.
Ready for the museum. It definitely did its job. It was used over the course of the summer for that stress testing while you guys were chasing down that heat, that USB issue anyway. So we'll see. I don't know. Maybe Nico can bring it back to life. Maybe one of you guys can. We'll cross that bridge another day.
All right. So let's keep working on. So the goal for the IoT Happy Hour is to put something on a cactus in the middle of the Arizona desert with cellular connectivity and your solar panel.
Yeah,
with a huge battery brick.
Yeah, we'll get there. We're still we've still got more learning to do, but that's why we've got the experts over that way and down there. So we'll get there.
All right. So thanks for coming at the episode 31. It was a pleasure to learn from you, Alex, Anush. And if you want to suggest any new requirement, any crazy idea for the Fin 2.0, go to the forum. It's on the chat, the link, and feel free to introduce your ideas, your requirements, whatever crazy idea you have, because maybe our engineers, will think that it's a great idea and will include that into the newest Fin. So feel free. And
all right. I think that's it. I think we're good. Bye, everyone.
Thanks for coming, and have a good week.
See you guys.
Good weekend, by the way. Bye.
See you.